Oh, this is recording. Okay. So for the test this week, the definitions that you need to know are from the study guide A, C, D, E, I, J, and K. We're going to start with the study guide for Module 3 on question number 5. So Joshua, this says 2 vials containing air samples taken at different altitude. The first vial has 21% oxygen, 78% nitrogen, 1% other, and the second has 95% helium, 4% hydrogen, and 1% other. Which one came from the homosphere?
The first vial.
The first vial. How do you know?
Because the homosphere has the same, hollow is the same, and it's the same amount of gases, and 21% oxygen, 78% nitrogen, and 1% other are all just normal air.
Right. Right. So whether it's the troposphere, stratosphere, or mesosphere, the concentration of gases is going to be the same. In the homosphere, 78% nitrogen, 21% oxygen. It will just have a different concentration. Gases will be more concentrated closer to the Earth, like in the troposphere, and less concentrated in the mesosphere, but the same overall amounts of the different gases proportionally. And the 95% helium, 4% hydrogen, that comes from the heterosphere, because there's a layer of the heterosphere that's predominantly oxygen, and then a layer that's predominantly helium, which is where that came from, and then a layer that's predominantly hydrogen. Number 6, Anna, you are reading data that comes from a balloon, and I might actually have different questions because this study guide is still from the first edition book. So if my question is different than yours, let me know. So this balloon is rising up through the atmosphere. You don't know how high it is, but it's sending the temperature readings as it goes up. So how will you know when the balloon enters the stratosphere?
It will get warmer, then in the mesosphere it will get so cold it will freeze.
Okay, so perfect. As you go up to the troposphere, the temperature will decrease, but as you go up to the stratosphere, the temperature will increase. And then when you get into the mesosphere, the temperature will decrease again. And Lily, what are the 3 regions of the homosphere from lowest to highest?
The troposphere, the stratosphere, and the mesosphere.
Perfect. And we've talked about those quite a bit in the project we just did too. So, Elise, yes? Okay, I've got it now. Although the temperature gradient changes from region to region in the homosphere, there is one gradient that stays the same. This continues to decrease as you increase in altitude, no matter where you are in the homosphere. To what gradient am I referring? Is that the same question you have? Okay.
Amount gradient.
Tell me loud.
Amount gradient.
That's true. The homosphere will, it's not even a gradient. The homosphere will have the same percentage of gas, 78% nitrogen, 21% oxygen throughout. That stays constant, and that's absolutely true. How about amount of air particles in a given volume, like air density or air pressure? What will happen as you go up through the homosphere? Is the air denser here on the ground, or is it denser as you go? Okay, so density of air decreases as you go up through the homosphere. So air pressure decreases. Like if you stand up on Mount Everest, air pressure is less because that column of air is shorter before you get to space. Down here at sea level, pretty much where we live, there's a much taller column of air before you get to space, so air pressure is higher the lower you are. Okay, Bethany, a plane is experiencing a lot of problems because of a storm in the area. Is it in the troposphere or the stratosphere? Troposphere. And how do you know?
Because there's more air in the other areas, and so you have less resistance in the troposphere.
Right. How about weather?
Weather is also farther down, and there's not as much weather higher up.
Right. Once you enter the stratosphere, there's virtually no weather going on. Number 10. So Ava, a scientist has 2 vials of ammonia gas. She tells you that in the first vial, the gas molecules have an average speed of 20 miles an hour, and in the second, they have an average speed of 23 miles an hour. Which is the higher temperature? Is your question different? Read your question nice and loud.
Scientist has two vials of moving gas, which tells you that in the first vial, gas molecules are traveling with average speed of sound. In the second vial, they're traveling with average speed of sound 300. Which vial contains the gas with the higher temperature?
Okay, so which one? Okay, so the larger number of, so the faster miles per hour would be the higher temperature. And why is that?
More energy, higher temperature.
Exactly. Particles with more energy move faster and they have a higher temperature. That's kind of the definition of temperature. There you are. So Chris, as you, tell me if this is different, as you're outside on a cold winter night, you begin to shiver from cold, but your companion says you're shivering from heat. Is he correct? Why or why not?
He is correct. You're shivering from the heat of your body reacting with cold.
Maybe. What's the definition of heat? Is it on the front of your study guide? Oh, you wrote them on notebook paper.
Energy that is transferred is a consequence of temperature differences.
Right. So if you are shivering, what temperature difference do you have? You are...
Cold, and you are warm.
You're warm and your surroundings are... So heat is moving...
Out.
Yeah, from your body out into the surroundings. So you feel cold because of the cold air touching you. You are losing heat to your surroundings, and your body wants to stay a constant temperature, right? You're warm-blooded. You stay 98.6 Fahrenheit. So when your body's losing energy to its surroundings, what does it have to do?
It has to generate.
It has to make heat, so you shake. And that was bad camera. I'm like shaking. Yeah, it's like a special effect, guys. Special effect. So yes, you could say, and there's a test question very similar to that. Just remember, the definition of heat is important when you're talking about this. So heat moves from where it's hot to where it's cold. So pretty much any kind of heat change is, you know, for even freezing is, like say water's freezing, that's a consequence of heat because the water is losing energy to its surroundings. So the ice is getting cold, but the surroundings are getting hot. So freezing is a consequence of heat. That's sort of a tricky question, and he really does ask one like that on the test. Number 12, suppose there's a layer of carbon dioxide gas in the mesosphere. What would happen to the temperature gradient there?
It would reverse.
It would, because the mesosphere tends to get what?
Rise up higher.
Well, it does, it goes up, but the mesosphere gets colder as you go up through it, right? But if it had a layer of carbon dioxide is what kind of gas? A greenhouse gas. So carbon dioxide is a greenhouse gas. So as you go through a layer of a greenhouse gases do what?
Rise.
But they... Help her out. Joshua? Greenhouse gases do what?
They trap heat.
Okay, so they trap heat, they, you know. So just like in the stratosphere, it actually warms up as you go through the stratosphere because the ozone layer is there, and the ozone layer is a greenhouse gas. If the mesosphere had a layer of greenhouse gas like carbon dioxide, methane, water vapor, or ozone, then you would see an increase in temperature as you went through it because greenhouse gases trap heat. Okay? Is that a different question than what's on your paper? I'm always worried about that. I should make notes about it. So Meredith, why will a ban on CFCs not really produce any saved or improved lives? We didn't talk about this at all.
It wouldn't change anything.
For who?
For us.
Why? It would change something. Anyone? remember? Okay, so Patrick,
The ban on CFCs really is gonna cause more deaths.
why?
Well, because CFCs are used as firefighting equipment to help put out fires. Air conditioning, people might die of heat stroke and,
We're really wimpy.
I don't know. Yeah, things like that.
CFCs are also, yes, there you go, tell us.
The sterilizers which are used during like surgeries to help reduce pain
Well, it's to reduce infection.
Yeah, reduce
Because
infection.
if you have bacteria on the thing you're doing surgery with, you introduce bacteria into the human body, it can grow, you get an infection, it's bad. CFCs are a great way to sterilize the equipment that you're using, kill the germs, and so between firefighting and not sterilizing our surgical equipment and stuff, there may be a loss of human life. But what do CFCs do that have caused the government to want to ban them? We'll go back to you. It's your question.
Wait,
Why has the government instituted a ban on CFCs, that's chlorofluorocarbons? Joseph?
Because the chlorine, will destroy ozone, and it's part of like the ozone, it can go up to the ozone hole and like destroy ozone.